Right, this is a quick introduction to the Tello drone, which is a picture over here, and this is the supporting code for it. Just going to go through some of the basic things you can do with it. So there's some quite simple. This drone allows you to move it around in X, Y, Z, and also use a forward-looking camera to see what's going on, and on the basis of the images that you get from the camera to move the drone. Now, it's got some quite simple commands, like say take off, land. So it's got some quite simple stuff which I can explain to you in detail as we go through. It's also got things like move back, move forwards, move left, move right, move up, and you can specify the distances in meters. You can also control the speed at which it moves as well. So you've got different commands you can use which allow you to move the drone around. And so you say move forward, distance 2 meters, and wait until done false allows you to interrogate what the drone does as it moves. So if you did move forward, say 5, it would move forward for 5 seconds. So there's different types of commands you've got here. You have to learn how to use them, but they're quite easy. So you've then got move up, move back, move up, move down, move left, move right. So they're quite nice little sort of simple commands. You can use this then to move your drone about. You can also do things like turns. It works in radians, so you have to convert them from your degrees to radians. It's also got sort of slightly strange command you call flip. If it's a certain height off the ground, say at least a meter or two, you can get it to do a little flip. Not that you'd want it to, but you could. Now, getting data from the drone as well, it's possible to get data from the drone. And so you can get height data and you can get speed data from the drone. So you can, that's speed in X, Y, Z, and height, just height. And you can also get yaw and yaw angles as well. So they're available through a read height or read data. It comes back as whatever the variable is and the time at which it was taken as well. You can also use the camera. It's the camera at the front here, and it's got a forward-looking camera. You can do preview, and that whatever it sees, it puts on your screen in MATLAB real time. Close preview, so you can get windows. It's got quite a lot of commands, vision processing commands, which you can then, whatever it's seeing, you can process the image to make decisions about what you want to do. You can do snapshots, again by using the camera to take pictures, and there's relatively simple code for doing that as well. So you can, the project does involve using some form of vision to move the drone about. So you've got some code that moves the drone and some code that does vision, and you integrate the two together to make it move about using the vision system. So the projects have to be based around that. Now, one of the issues with the height measurement and all the measurements is they tend to come off. They don't come off the signals very nice. They're quantized. So instead of being a nice smooth signal, they tend to go in steps of about 0.1. There's a bit of a resolution problem with the drone itself. So if you did a height change, this is its change in height of say 1.5 meters, but the graph sort of comes off at a bit of a sawtooth, which doesn't look quite as good. So one option is, if you measure its change in height, if you integrate speed, you can get height. So what we're doing is to get the height signal, we're integrating speed. So measuring speed, integrating it, and then this is what we get, this sort of nice, more smooth line here. It's probably a better signal for demonstrating in graphs and things, because it's more appealing to the eye. So rather than using the height measurements you can use, but if you want to get nice sort of graphs, you're better off using speed and integrating the speed. It's not very hard. I've got code for doing all this. This is just an introduction to get you an idea what's going on. So here's typical integrating speed signal for 1 meter movement, and here's an integrating speed x for 2 meters. So it looks like a sort of plausible movement of the drone. You can also get it to, because MATLAB's quite sophisticated, if you get it to move in 3D, it's got a 3D plotting routine, so you can plot the motion of the drone as it moves about in 3D as well. So you've got quite good access to plotting out graphs in the report. If you're doing a final year project, you need to plot out graphs and show what happened. You can do a distance against time graph. You can also do 3D plots as well. This hasn't got time in it, so it's just telling you how the drone eventually moved in the total space over time. This is another little example that I ran. What I did was it uses the drone vision system to follow a green dot. The signals that come on the camera are RGB, red, blue and green. So if you put a green filter on, I put a green dot in front of my telly, and then the drone flew up and it would then move to try and locate itself on top of the green dot. And this is the XY, so it's X and height movement as it moved around in this space. This is the graph that it plotted out, and you can see eventually it's meant to end up at 0, 0, which is here. So you can see it starts off here and then moves around and eventually sort of zooms in on that point there. The thinking behind this was that if the green dot was there, and this is your drone, it needs to move up and to the left. So it then move in, well, it took the worst ones. If this was bigger than this, it would then, well, say this was bigger than this, it would then move this to here, move the drone left, going to do one movement at a time, and then having got to it, then it would move up. So say it was up here, and this distance was bigger than that one, it would move that way and then up. If this distance was bigger than this way, it could move that way first and then that way. So you can have strategies then for moving the drone about to get your different graphs here. So you can invent your own strategies, but I just invented a simple one. And another thing that possibly could be done with the project, there's a website where somebody's made a little 3D plastic thing with a mirror here, and it then allows the drone to look downwards rather than forwards. So you could potentially, there's a website with this drawing on. You could download the drawing, you could get the makerspace people to make it for you, put it on the drone, and then you could have a downward looking drone, and it could then follow possibly a green or blue or red line on the floor and fly around that, so fly a shape. So that's one. There's all sorts of things you can do with the drone, but that could be one. Another could be like facial recognition. It's got quite nice facial recognition software. You can recognize faces or fly towards faces, or recognize objects and fly towards objects. So that's some of the information I've got now about this this particular drone. It connects up to your Wi-Fi on your laptop. You can have one to take home. You can program it in to move about, and you can start playing about with the vision system and using the vision system to either look forward or possibly look downwards using a mirror, and then make it do some intelligent, semi-intelligent tasks. You could run 2 or 3 projects on this, but it's quite a reliable drone, and I haven't really crashed it badly in the time I've had it, and I've got loads of little programs. Got loads of programs that I've written already, so you haven't got to write much code at the start. You can just run my programs and you can figure out how to do it. So that's another project.